Hi, everyone, and welcome to the Docker Best Practices track. I'm Christy Howard. I'm a software engineer here at Docker, and I'm very excited to announce our next speaker, Ada Mancini, who is a support engineer at Docker on the Enterprise Editions team. Fun fact, Ada is an avid fire performer. So please give a very warm welcome to Ada for troubleshooting tips from a Docker support engineer.
All right, thank you. Welcome. My name is Ada, and I am a support engineer with Docker. I've been there for the last 4 months, and this is my first DockerCon, so thank you very much for being here. Who here has deployed software on Docker Swarm or is part of a support team, regularly does problem solving? I'm sure, many people. We all know problems are inevitable. Whether they're software or hardware or human issues, we deal with problems every single day. And we know that no software can be perfectly bug-free. But who's ever had a bad experience with a customer or technical support situation? I'm sure a lot of us have probably been frustrated by a bad engagement with a support person, or you've experienced a problem and you reach out for help and that back and forth takes too long, or you don't quite get the answers that you were hoping to find, and perhaps you don't have a support contract for a piece of software that you're working on, or the solutions are completely up to you to find. So the biggest critical factor for us is time and the way that we respond to these issues. I'm sure that we all wish we had more time to do the things that we would like to invent and create and spend less time on fixing problems. So what I want to talk to you about today is how you can improve your troubleshooting processes and spend less time fixing things and more time creating and working on the things that you're passionate about. And that when you need to ask for help, you know how to get the answers that you really want. We strive to be the knowledge experts on containers and distributed applications, and I want to show you some processes and tools that I use in my day-to-day work to solve problems with Docker and Docker Swarm, and ways that the Enterprise Edition can make this a little bit easier. So what is troubleshooting exactly? It is a systematic approach to solving problems. It's an algorithm that you apply to complex systems to break them down and identify problems and solve them. The algorithm that I've always reached for is the scientific method, a process for making inquiries and solving problems. I'm sure that you're probably all familiar with this, but it always starts with a question that we pose to ourselves, or a question that we're asking someone else. What has gone wrong? Or why did my application crash? We take what we know about our systems and the questions that we're facing, and we form a theory, a hypothesis, an educated guess. And we must test that hypothesis and analyze our results, and either the results will support what we think we know or they don't, in which case we make new theories, new hypotheses, and we continue testing until we're satisfied that we have an answer, or we can't find one and we're stuck. We need to ask for help. Once we have that answer, we want to communicate that to others, our team, our coworkers, the public, because knowledge that only belongs to one person, it doesn't help anyone. It may solve your problem here and now, but what happens if you leave the company, someone has to take over you, you get hit by a bus? That's no good if knowledge is all locked into our own minds and we don't share that with other people. So, in the event of asking for help as well, where do you want to go if you have to ask for help effectively? How do you get the answers that you need? I like to break this down into 3 major components. Makes it easier to remember. Characterize, test, and analyze. So how do we begin characterizing problems? Where do we start? It all starts with questions, and asking better questions is one of the main things that I want to talk about today. So this is a conversation that I have had with people before, and its names are changed to protect the innocent. But a user asked me in IRC how to access SSH on their container. Typically not a recommended way to get inside a container. If you're running an application container, one container, one concern, and we don't usually recommend that you run an SSHD in addition to other applications. You would need some sort of process supervisor to make sure that all of your processes are running together. You get the increased attack surface of SSHD. But as this conversation goes on, we see that the question is not really about SSH. The question posed is, how do I access a GUI program that's running inside my container? Forwarding an SSH session over X is not really the best way to get a GUI container running. It's a lot simpler just to mount the X socket. This is an example of a real Docker run file where we can mount the X11 socket, we export a display variable, and we can bring up a Firefox application inside a container. Much, much simpler than trying to shoehorn extra processes into our containers just to access them. So the definition of this is the XY problem, and that is asking for help about what you think the solution to a problem is without actually bringing up your end goal. And this is an unconscious bias that I encounter all the time. This is something that we want to keep in mind when we're asking ourselves or others these questions to not lead us down the wrong path. The formulation of a problem is more essential than the solution. If you have not started at the right starting point, you start to walk down a troubleshooting path, and you arrive at a conclusion, it's probably the wrong one, if you've asked yourself the wrong question to begin with. So that's the crux of my session today. Why did my container crash? What's going on with my applications? We want to take a step back and always remember to analyze the big picture. The first thing that I always reach for in doing this characterization before asking these questions is looking at our logs. I'm really into logs, metrics. Those things make me very happy. And Docker gives us really powerful tools for doing log collection and aggregation. The Docker daemon captures standard out and standard error file handles from a container and presents them as streams to the Docker host via the command line interface. SwarmKit services even get a special multiplex set of logs. You can collect all the logs from all of your containers across all of your nodes using the Docker service logs command. And UCP has some interesting features to make this simpler as well. Here's an example of a Docker file of how we might organize an application to ensure that we capture the logs from an Nginx container. You can see highlighted here, we take the standard out and standard error file handles and link them into the place where Nginx would normally log to file. This is an example of an Apache container. This comes from the library. Apache is a little bit more complicated configuration. So we are using a sed in a run command to point file handles 1 and 2 to the standard Apache log files. If you're familiar with Linux I/O redirection, file handles 1 and 2 are the standard out and standard error streams. For some applications that are too difficult to change their logging infrastructure, or perhaps you don't want to change any code, maybe it's part of a modernization of a traditional application, here we can see an example of a Tomcat service. And this is a pattern that I've recommended in the past. We don't really want to change the application code that's running inside our container. But when we create our service, what we can do is create a volume and mount it into the file system location where our application would normally write its logs. Then a log processor or collector on the host can examine that volume, and you can still get all of the events captured that you need in order to do the research to characterize problems. UCP also gives us some really powerful, a really easy tool for doing these log dumps. In the Enterprise Edition, we have a very nice feature called the support dump that in one click will create a tarball of all of the Swarm and Enterprise applications, the Swarm and Enterprise containers on your network and dump them into a tarball. You can provide that to a Docker support person, and hopefully that is a one-click pathway to finding answers or debugging your Swarm. I can show you an example of how we might do some log searching through the support dump as well. So what is in the support dump? It is a list of files get this. So we have here a copy of inspect and logs from all of the containers that are running on our network and all of the agents that serve the Enterprise Edition across our swarm. This is a simple 3-node swarm, 1 worker, 1 UCP manager, and 1 DTR node. And all of the logs from the daemon are included as well here. So I will jump back to this in one of our demos, but let's continue on. The UCP GUI is the standard way that we would dump these logs, but let's say you have a problem with the GUI, it's not loading, one of your managers might be down, but we still need to collect all of this event data. The support dump can be run through the UCP Bootstrap container very easily. You could script this into a Ansible job or something like that to run it across all of your nodes in the event of a UCP failure. And you could provide that to a Docker support engineer, and we will help you do the research and get the problem solved. So, after characterization, we want to test our hypotheses. We want to form some theories and try and figure out what's going on inside our applications. One of the best ways that we have to do this is the NetShoot container you might be familiar with. I believe Nico may have given a talk that covered some of this, and Nico is one of our employees. It's a very, very handy Swiss Army knife type container. There's lots of network troubleshooting tools included in this, and it is essential in my work. You could run this in a container's network namespace if you believe that there is a problem with some container networking, or even the host namespace if you believe the problem lies on the host side. I stole this slide from the DockerCon in Austin. This gives a simple overview of the Swarm networking setup. And you can see that we create VXLANs and virtual F devices for each one of our hosts and containers that allow these containers to speak over a virtual overlay network. So I want to show you how we might use one of the tools in NetShoot. We call NSEnter. And let's create an overlay network. Overlay. Enter. All right, so we have ourselves an overlay network. I'm going to save this network ID because I'm going to need it later. And let's create some fake services on this network. So we're going to bring up a BusyBox container, and if I can manage to do this without creating any syntax problems. Okay. So we have here a service that we just created. It's being replicated out right now to 3 instances. And we want to examine what is going on inside the network namespace for these containers. So what I'm going to do is launch our handy NetShoot container attached to this namespace. Run Docker NetNS. All right, so now we're inside NetShoot, which is an interactive container. And in order to use NSEnter in this way, we actually need to use the privileged flag because it requires some of the capabilities that are normally dropped when running containers. And let's take a look at the location that we have mounted, which is the varrun docker netns directory. This contains a list of all the namespaces that are included with the overlay networks that we have. And we can see that the one that I created is this uvvj-ms, and we have here a namespace that matches that ID. Typically, swarm overlay networks will start with a digit and then a dash. So this looks to be the right namespace that we're interested in examining. So let's jump into this namespace. Docker netns. And we need to bring up a shell. All right. All right, let's take a look at the ifconfig here. So we can see that we have a couple virtual Ethernet devices and a VXLAN. And let's take a look at the ARP table. Great, so there's our VF devices and our VXLAN. And these are all hooked up to, let's see if I can jump back to my slide. These are all hooked up to a VXLAN device that are coming out of 3 containers on one host. Each one has its own virtual Ethernet device connected to a bridge, to a VXLAN that goes out through our physical network to the rest of the hosts on our swarm. All right, let's look at the routing tables. Okay, so we have a standard route that instructs all of our containers to travel across. And let's look at the neighbor table. Make it larger? The bottom's cut off. Let's see. Let's make that a little higher. Is that better? Great. All right, so it looks like this neighbor table is empty. Let's ping some of the containers on this network and see if we can get this filled in. So we are on 10.02.1, and let's see if we can find the. All right, so a container is responding. There's another container. And there is another container. Great, so this is our ARP table. You can see that NSEnter is extremely handy for jumping inside of these namespaces and examining what's going on inside your swarm. The namespaces are isolated from each other, so by default you would not be able to see all this information if you were just sitting on a host. You need to be able to traverse these namespaces. And there are namespaces for the network, for PID, for mount, several others. Let's look at the bridge configuration inside this namespace as well. Great, so this is our bridge configuration, and it is hooked up to our VXLAN and the 3 virtual Ethernet devices that match up to our 3 replica containers. So, Standard troubleshooting, we use a number of tools that are standard Linux command line utilities. NetShoot includes several of these, but very, very often I use TCP dump for inspecting network traffic that is moving back and forth across one of these interfaces. IPVS, ADM, IP tables, route, IP, these are all fantastic for examining network configuration. SOCAT and NetCat are for bidirectional communication over a TCP or Unix socket. You could craft packets in whatever manner you choose and use that for debugging and troubleshooting. Most of the Docker APIs all speak HTTP, so curl is a fantastic tool for interacting with the Docker APIs. And all of those APIs return JSON. So JQ is an excellent command line utility for manipulating, creating, and sending JSON text through the shell. grep and awk, I'm sure a lot of you are familiar with. They're fantastic for searching and manipulating regular text. Now, I want to make a quick segue and talk about a subtle issue with swarm overlay networks. This is something that I encounter from time to time, and it has to do with the difference between swarm services and regular containers. So swarm services are declarative, and regular Docker container run is an imperative operation. SwarmKit uses desired state reconciliation to ensure that the swarm is in the state that you ask for in the service spec. So Docker is secure by default, and swarm overlay networks do not allow you to run arbitrary containers of them. It would be a violation of that design principle to allow a user to simply attach any container to any network. If you're using swarm overlay networks, some of them might be isolated, some of them might be secure or encrypted, and we don't want just any person with access to the Docker daemon to throw arbitrary containers on these networks. We want to ensure that Swarm is managed by a service spec and that it is in our desired state. So having random containers that are not tracked by a service spec, that's not a good design principle. So in order to get a regular container on a Swarm overlay network, we have a special flag that you need to use. We call it attachable. This is a useful technique for actually getting one of these debug containers onto an overlay network if you have to. So what I have done before is standard Swarm service is deployed on an overlay, and we want to bring up something like NetShoot attached to that overlay to inspect a container, but we need a way to allow that to happen. So we create a network with attachable set to true, and then we would attach our service to this network. Doesn't detach it from its existing network, it just also joins. And then we could bring up our troubleshooting container attached to this overlay. We could poke around in whatever namespaces we want, exit, and then we can remove this network without any interruption to our services. So I spoke a little bit about the APIs that were available in Docker, and Docker has this fantastic API browser now in the latest version of UCP that lets you do these API calls interactively. I understand that this example is a little small, so I'm just going to bring it up in the browser and show it to you. Can everyone see this? I know it might be a little small. The DPI in this laptop is a little high. But we have a list of all of the endpoints that are exposed by the Docker daemon. And through this browser, we could say, look at all of the containers that we have deployed right now. I can click on this, open this up, and this is a live API call that will run in the browser. If I execute this, I will get a response here in JSON that is a list of all of the containers attached and all of the container inspect data. You can do this for all of the API endpoints. So if you're trying to program custom integrations with Docker or Enterprise Edition, this is extremely handy for debugging and troubleshooting your API calls. And if all else fails, we go to the source. So Docker is an open source company, and all of our code lives on GitHub. Through some of the GitHub's advanced search utilities, we can search across the entire organization, all of our repos. If you're not sure where to look for a particular error message, or you're trying to do some research, you could, like in my example, choose the org Docker. We're going to search for an issue that has been closed because we're looking for solutions. And let's say we're running 1703 and we have an issue with swarm health checks. There was a bug in 1703 where the health check was not respecting the startup time. So let's say you are running a service and you know it will be consistent after a certain period of time. You could script in a wait period that would say, don't run a health check for 30 seconds or 1 minute. Don't report that this service is failing before we expect it to be ready. So we've spoken about characterizing issues, done some research, and once we have this information, we want to test our theories. We want to find results and determine if our theories are correct or not, if our characterization is true. So for this, I'm going to turn to some more demos. So we have on our swarm a couple of stacks that are running WordPress sites. Here's one that I threw up really quickly, just another WordPress site about DockerCon EU. And let's try and expand this. Let's say we are running a business and we're standing up WordPress for a number of customers. So let's launch a new WordPress instance. Let me show you the service spec that we're working with. So it's pretty standard. One database service, one WordPress. Database is on a backend network, and we're using MySQL. We're using a volume to store this data. And we have WordPress connected to a front end for actually serving our content to people in this backend network as well, so it can speak to the database. This backend network might be isolated so that there's no internet connection to it. And we're going to take this service spec and try to create a third stack. We have a new customer. We're standing up a new WordPress instance. And we would expect our stack create to succeed. We create a service, WordPress 3's database, WordPress 3's WordPress instance is coming up, and we should be good. Yep. All right. So we have another WordPress. And let's take a look at the port binding that it's been assigned. Something's not quite right. So let's try and figure this out. So we've got some services, and it looks like the WordPress service has failed. But it's not telling us why. Let's take a look at the containers that are behind the scenes in this setup. And it doesn't seem like we have a container. Well, let's take a look at what tasks have been scheduled to maintain the desired state of our WordPress system. Here's our task template. And so we have a task that's being assigned to a node in the network, but it's failing to actually create some kind of container. The next place that we might look is the logs. Like I said, the logs are the most important place to capture events and to do this sort of research. All right, so we see here in the daemons logs a failure to create a network allocation for this task, failure to allocate the network IP for the task. It could not find one. So let's take a look at the network configuration on this node. We jump back to UCP. So we have a front end and a back end network. Let's take a look at the front end. And we're just examining some information, we're doing some research, but we notice this subnet. And this 29 CIDR address, this seems pretty small. This is probably the reason why we can't assign an IP to our container, because there are none left in this network. So we would create a new network. And we could go back into our service, and we could configure this service, and let's see, instead of this front-end network, which is saturated, let's put this on the new WordPress front end. Service update will go out. It will say reschedule these tasks, update the configuration of this container, and we would expect, there we go, we're all green. Let's take a look at what IP address has been assigned here and see if we can see our WordPress site. Great, a new WordPress install. So it looks like we are getting a little close. Does anyone have any questions at this point? All right. So part of what I want to get at as well is that containers are great. We all love containers. That's why we're here. But they're not magical. They're not a silver bullet for solving problems. So running applications in containers doesn't absolve you of the responsibility for understanding how your containers perform. When you need to ask for help, let's say that you have hit a block and you're not sure where to go from here. Your characterization, your research, and your testing hasn't produced a result that you're happy with. How do you ask for help? We start by asking questions, as always. This is an example of an unhelpful question. My Docker file doesn't work. Has anyone ever gotten a support request that sounded like this? Because I get these a lot. Yeah, this is really unhelpful. It gives you nothing about the context. None of the research has been done. If you are starting over, you're basically beginning at the very beginning of the trail and trying to recreate someone else's process to rediscover the problem that they found. It's a very big waste of time. So this is more helpful. My Docker file that uses from Ubuntu fails to build when it reaches a particular run step. It's a little bit better, but it's not quite there. Let's look at the most helpful form of this. My Docker file that looks like and a link to the complete Docker file. It fails to build when it reaches a certain run command, a certain run step. And I have tried methods X, Y, and Z to fix this, and none of those have worked so far. And it still fails to build with the following error. And we show evidence of the error itself. This is great. This puts us essentially all the way at the end of the scientific method. So if we started at a question, all of the research, some testing, some hypothesis, some analysis has been done. We want to get to conclusions as quickly as possible. So providing all of that information when you ask for help is extremely, extremely valuable. So where do you ask for help? Docker has a number of avenues for getting help and assistance with debugging your applications or debugging Docker itself. My favorite one is IRC. I'm on IRC all the time. You can find me there. My username is Ada. We also have a community Slack channel where community members help each other. It's very similar to the IRC channel. It's all community run. It's excellent. There's a lot of great teamwork and collaboration that goes on here. We also have a community support forum as well. And if you're an enterprise customer, we have a support portal for enterprise customers where you can talk to support engineers like me and my team, and we'll solve problems together. We have an excellent knowledge base that I'm really happy to say just got a new backend. It's all based on GitHub now, and it's way more searchable, and it's way easier to use. And we also have an excellent set of docs on our documentation site, tons of guides on reference architectures, simple things, how to manage Swarm, how to manage services, how to design a proper logging infrastructure for your distributed applications. Fantastic, fantastic guides. All of these also live on GitHub, so anytime you have a question or you think something needs clarification, I'll accept PRs. I write new knowledge base articles every day, and it's a great, great resource for finding information. All right. Thanks, everybody. Does anybody has any questions? If anybody has any questions, I will be here. I'll also be at the hands-on labs over in the experience hall. If you've run into problems, you can come ask me about them there. You can also run through all of our workshops and do some self-paced learning. And if you're interested in the Enterprise Edition or you just want to try it on your Swarm, we are hosting demos of the Enterprise Edition trial. You can run workloads on these and you can try it out. You can collect support dumps and do some characterization.
Let's hear one more round of applause for Ada.
Oh, and if you don't mind, this is my very first DockerCon, so I would very much like to take a Docker selfie with you all. Please. All right, thank you so much.